Sorry, I'm out of practice. But the pre-recorded videos, the ones that say LV, most of them were re-recorded in the last 2 weeks. Some of them haven't changed from last year, but most were re-recorded in the last week, so they're pretty new. Yeah, I'll do extra stuff in the live lecture. The big advantage to you in the live lecture is you get to ask these live questions. Whereas in the recorded videos, well, I was by myself or with the dogs, one of the two. Um, I would, well, if you look at the sample code, I call the sample code C++, but in fact it's C with maybe one thing from C++. I would call it .cpp on the file name, but by and large it's C. All right, I think that's everything. Yeah, like I said, I will go check on the rabbit situation, because yeah, it's important to use the one with the cooler name. All right. Well, let's go to more OpenMP information. There's a note set called Simple OpenMP, and it shows up real early in the list of notes. And there we go. And this is exactly what it sounds like. It is a simple introduction to OpenMP. It's there to get you into Project Zero. We will take a deeper dive on OpenMP, but this is the Cliff Notes version. Okay, first of all, OpenMP is an industry standard. It stands for Open Multiprocessing, and it is endorsed by a ton of companies. You see computer companies in there, round up the usual suspects: AMD, ARM, IBM, Intel, Cray, Fujitsu, Hewlett Packard, and so on. It's got national labs like Argonne, Lawrence Livermore, Sandia Labs. It's got cool places like NASA. Um, it's got software companies like Oracle and Red Hat. So this has been around for probably 25 years, I'm just guessing. And it improves. It's got new development. We're using it at a pretty base level, which means you don't have to worry if your system doesn't have the very latest. Whatever your system's got will work for what we're going to do. But the cool thing is that OpenMP, you you give it information, and the compiler puts the parallel code in with your code. So really, OpenMP is implemented in the compiler. That's one of the cool things about it. I think it gives you the biggest benefit per the amount of work you have to do because, well, you don't have to do much work at all other than asking for things to happen. Yeah, it's OpenMP that's doing all the work, adding things into your code through the compiler. And here's how it works. Every so often in your code, you will put in a line that says pound pragma, OMP, some directive, some word, and then maybe some additional information out here. And that's it. The compiler finds that, and the compiler adds code into your code to do those things. Okay. Now, one of the things you're going to hear me say all term long is doing parallel processing at all is not difficult. Like, how hard is it to type pound pragma OMP something a few times in your code? Like, I could go get a middle schooler to do that for me. The trick is doing parallel processing well. There are issues that we'll get to. There are issues in how you have to format a for loop to be parallelizable. There's issues in cache, managing the cache. Okay. And so there's issues in synchronization. So this is your value added. So yeah, this is why you put this on your resume. is because this is not just put in the pragma and call it a day. There are issues that make this work badly or make it work well. And so really, our job here is to help you make it work well. Okay, using OpenMP. If you're on Linux, if you're on Flip, if you're on Rabbit, when Rabbit allows you in, you use G++ just like you always have, except at the end you say -f OpenMP. Okay, that just turns it on. One, it turns it on. Otherwise, the pragmas do nothing. Pragmas are allowed to be ignored by the compiler. So if you haven't turned OpenMP on, it's going to ignore the pragmas. Also, there's an OpenMP library, and -f OpenMP brings that in as well. So that's all you have to do. Then you just run this executable. In Visual Studio, it's off, OpenMP is off by default, but you go to the project menu, project properties, configuration, C++, language, then you'll see something that says OpenMP support, no. Change that to a yes. Okay, now it knows about it. Visual Studio, being what it is, every so often when people are using OpenMP, it gives you this message. And I can't even parse the English for this, but we did find out that this is how to fix it, make the message go away. So I'm just throwing that out there. You probably will never see this message, but if you do, and here's how to get rid of it. Okay, see if OpenMP is supported on your system. If it is, if you've done the -f OpenMP, then this underbar OpenMP is a defined variable. And so if I say, if that's defined, print this, and that prints the version number. But that lets you know that OpenMP is supported. Else, well, it's going to print it's not supported, and it's going to exit, because well, whatever you're running it for, it's not going to happen. The easiest way to make it seem like OpenMP is not supported is to not do the FOpenMP or not do this if you're in Visual Studio. If you do those things, then you should get this edit supported message. All right, threads. We're going to get into threads in more detail probably next week. But basically, a thread is an independent path through your program. All of the threads are going to share your one executable, but they're going to be at different places. They're going to be executing at different places. Okay, but all the threads share the same executable. They share the same global variables, and they share the same heap. Okay, the heap is malloc and new, dynamic memory. So if one thread allocates memory on the heap, any other thread can go look at it if they know the name of it, or the address of it. Okay, so yeah, we'll get to this, but OpenMP is really multi-threading. Okay, so here's how to see if it's supported on your system. Here's how to find out how many hardware cores your system has, which is always an interesting number. It actually gives you the number of hyperthreads, and we'll go over later in the future what that actually means. This is how you specify how many threads you want to use. So as you're running testing with 1 thread, 2 threads, 4 threads, you'll pass into this function the number of threads that you want this one run to use. But here's what you need to know for Project Zero. Probably the biggest use of OpenMP is to parallelize for loops, which makes sense, right? A for loop is essentially do the same thing, but on multiple data, multiple pieces of data. Well, that's perfect. Let's just crack off a fourth and give it to thread 0, crack off a fourth, give it to thread 1, and so on. And that's what's going to go on. You say OpenMP set num threads, and numt is, I like to use that in the code for a defined constant. So for Project Zero, it's going to be 1, then your second run, it's going to be 4. And that doesn't actually make the threads. What it does is it just says, next time I make threads, here's how many to make. It's the pragma OMP parallel, like up to the word, through the word parallel. That's what makes the threads. So say you set this to 4, the moment you say pragma OMP parallel, 4 threads emerge. And when it sees the word 4, it's going to divvy up your for loop on those 4 threads. Okay, so this is what we're doing in project 0. Don't worry about this default none. We'll get to that when we do the deeper dive into OpenMP. A second. Okay, so question in the chat. On Linux, will the distribution have OpenMP installed? It's not installed in Linux. It's installed in the compiler. If you use the G++ compiler, then OpenMP is indeed installed there into it, and you say -f OpenMP. Oh, interesting. The platform. Oh, okay, right. Yes, the platform dropdown should be the same as what you're compiling. Yes, that makes sense. I work at a company that doesn't allow OpenMP. Ha! Well, there C++ has a threading library, and there's others. Intel has DPC++ or one API. Yeah, there are others. If you're in Java, Java's got Java threads. But yeah, there is a C++ threading. It's just not as convenient to use as OpenMP. Might be more efficient, but OpenMP is just a nice way of getting into multi-threading. Yeah. Yeah, again, OpenMP does not come with Linux. It comes with G++. Is there a way to compile the project on a local Mac which is running? There are there's some pieces of information on the resources page under the section stuff you should be interested in which I am basically repeating what people in other years who had Macs told me. So I would go look at that. Yeah, and if someone else gets it going and it doesn't match one of those things that is already out there, tell me and I'll put it out there. Yeah, this is the weird thing with Macs is sometimes someone will say, "Oh yeah, I got it to work. Here's the compile line," and then 10 other people will try it and it'll work for 2 of them. I don't know. Does Visual Studio Code work to run? Well, Visual Studio Code is really an interface to your system. It's not a compiler. Yeah, it's got a terminal in it. You can run from there. And you can compile from there because if you type the G++ line in Visual Studio Code, that should work fine. Okay, good questions. How do we know? Oh, how do you know if it's correct? Because when we grade it, we'll mark it as correct. No, that's part of the mystery of doing project 1 is you don't know. But how confident are you in your own code? That's the answer. Is there's a reason the probability is not listed in the project 1 handout. Okay, but let's talk about project number 0 right now. So project number 0, we'll go back to the class resources page down to here, click. Now, project 0, again, it doesn't deserve the dignity of having a non-zero number. Really, it's just an excuse to force all of you to get into OpenMP. Okay, because I used to just start with a project 1, and like your project 1 coming up, it's requiring you to use OpenMP. And what I found was some people were spending a whole week just trying to get OpenMP to work, and then they had no time left to do project 1. So this is the let's get OpenMP to work part of what used to be project 1. So this should take you about 10 minutes. Don't be scared about starting it. All right, pick an array size. One of the things you'll discover is small array sizes are not great for parallelism. If you need to multiply 10 numbers together, 10 pairs of numbers, don't do it in parallel. As you know, if you've taken OS1, creating processes, which is what threads are, they're processes, takes a while. There's a bunch of things that have to happen. Well, that's overhead. And so if you then you create a process and then apply a tiny amount of parallelism, the time to do the setup is going to swamp the time to actually do it into the process or the compute in parallel. So pick something big, something in the tens of thousands. Don't pick a trillion. Okay, that won't compile. You don't have enough memory. Don't pick a billion. You don't need to. But something in the tens of thousands are fine. And what you're going to do is you're going to make three arrays, A, B, and C. And the for loop is going to do A times B gets put in C. C of I equals A of I times B of I. That is the for loop. Okay. Right before the for loop, you're going to say pound pragma OMP parallel 4. Okay. That's just and then the word for. Yeah. And so that's the signal to the compiler. Take the for loop that you're finding on the next line and break it up into multiple threads. You're going to call this function, which is in the code, and pass in a 1 or a 4. So if you want to leave this pound defined, you're going to change the pound define to 1 to get it to run with one thread. Then you're going to change it to 4 and get it to run with 4. There's a call, this, that samples the system clock. Okay, we're going to use that to come up with a performance. The speed up is running it slow divided by running it fast. So the time to make that it runs in 1 second divided by the time that it runs in 4 seconds is the speed up. Okay. Or you can do a reciprocal and do performance. It's always big number divided by small number. Time 1 divided by time 4. Time 1 is how long it took. Okay. With one thread, which should be bigger than the time for 4 threads. Performance, though, the 4th thread should have more performance. So it's P4 over P1 or T1 over T4. You'll get the same answer. Just depends how you like to think about it. Okay. Yeah, so here we are. It's time 1 over time 4, or it's performance 4 over performance 1. Okay, that number should be greater than 1. You know from your experience with perpetual motion machines, it's probably not going to be 4. Yeah, it might be close to 4, but it's not going to be 4. There's always friction in there somewhere. There's always overhead somewhere. And we'll talk about that when we get to Amdahl's law next week. Now, you're also going to, so besides computing the speed up and telling us, you're also going to compute something called the parallel fraction. And that's the formula. 1 thread to 4 threads. If you know the speed up, S, this gives you this thing called parallel fraction. We'll explain that when we get to Amdahl's law. But it's handy if you have computed it now, because then you'll know what it means. You'll know how to interpret that when we talk about it. Okay. If you want to play around and do 1 thread to 2 threads or 1 thread to 8 threads, don't use this formula. This formula has 1 thread to 4 already built into it. Like that's why the fraction is 4/3. Okay. And you can find that formula in the Amdahl's notes if you care. So if you do 1 to 4, get the speed up, do that formula. Yeah. And then here's the code. And other than the size, you can pick something big. Here's the complete code. And I normally don't do that. I don't get used to this. I normally give you a bunch of code just because I don't want you to waste your valuable time typing it in. But the important parts I leave out, or I stick question marks in there so that you've got to go figure out what belongs there. But in this case, no, everything is here. Now, these timing functions, OMP, get W time, wall clock time, they're in seconds. And this code runs really fast. So chances are the elapsed time is going to be in the 0.00003 range, which means we need a lot of decimal digits because it's in seconds. So that's why these time 0 and time 1 are in double precision, and that's why the performance is in double precision. Again, we don't want to drop those decimal points. Now, when you print, if you print a floating point number, you write %F. And if you print a double, people jump to the conclusion you need %D. But %D is decimal integer. It's not double precision. Double precision is this, LF, which stands for long float. Okay, so when you're printing a double precision number and time or performance is a double precision number, use the LF. Okay, so there is the whole thing. Turn in your code. Your PDF should report on what speed up you got and what the parallel fraction was for that speed up. And it should take you about 10 minutes to do the whole thing. Please don't use up any bonus days on this. It's just not worth it. All right, let's go check the chat. I guess I better go up. Let's see. Visual Studio. Okay. Yeah, if you want to get Visual Studio yourself, and you can get it from the Microsoft's Azure for Education site, get Visual Studio 2022 Enterprise. Okay. There are some cut down versions of Visual Studio, and they seem to interact badly with GPUs. And so I don't recommend that. But 2022 Enterprise, I think, is the one you want to get. Is there a way to compile a project on a local Mac? Yeah, great question. There's a link up above in the chat to a Stack Overflow page, and there's a couple of entries in the stuff you should be interested in, which are things that people last year told me. If you find something, and I don't have a Mac, so I can't try it, but if you find something better, and I have no doubt there's a lot better stuff. Oh, works with no issues. Okay, well, if we go down, I just tested it on my M1. All right, good to know. Yeah, okay. Let's see if we have an AMD GPU. Anybody that I've had in this class who had an AMD reported that OpenMP worked just fine compared with on an Intel CPU. Okay, and that's the only information I have is there didn't seem to be anything different anybody had to do because they had an AMD CPU. As far as calculating the speed up, I would do it on a calculator. Okay, you're going to get a performance for 1, write it down. You're going to get a performance for 4, write it down. Punch those into your calculator. There's your speed up. You can add it to your program if you want, but it'll take you a lot less time to just do it on your calculator. All right, other questions? Questions in the chat? Questions you just want to unmute and ask?
Question.
Yeah.
Are we allowed to use the sort of sample main code in the Project Zero sort of handout, or
Yeah.
should we write our? Okay.
Oh, no, no, no. Well, Project Zero again doesn't deserve the dignity of a non-zero project number. It's just to get you in the game. But any code that I give you, if I give it to you in the handouts or the project handouts, you can use it. If I give it to you in one of the note sets, you can use it. So no, your time is valuable. I think your time is valuable. Don't retype something that you can copy and paste from something I've given you.
I asked about a AMD GPU, not CPU. It's basically AMD's version of CUDA.
No, we're going to use CUDA.
Okay.
Maybe some year we'll start using Intel's One API, which they're trying to kind of cover over all of that, but this is not the year.
One more question
Uh,
for you, Mike.
oh, yeah, go ahead.
Do you want, are we better off doing CPP files or C files?
I would just call it a CPP file,
Okay. Sounds good.
even
Thank you.
though even though how you use it might be more C than C++. Um, let's see, there was a question in the chat about Rust. Yes, I'm sure Rust has a way of doing parallelism. Um, C and C++ will get us through everything we're doing this term, and Rust will not. I guess if you have Rust doing OpenMP somehow, and it wouldn't surprise me if there was a way, you're welcome to do that. But for the multi-core stuff, the multi-threading stuff, please use the OpenMP. Okay, wow, good questions. Okay, other questions. OpenMP, Project Zero, how the class is going to be run. Well, I'll tell you what, we have a little bit of time. Let me do one more thing. There is a note set called Project Notes, and it's fairly short. But this isn't too bad a time to go over it. Okay, so it's called Project Notes, and it's there to try and clarify all kinds of questions about how do you do the project. Okay, yes, how do you set it up? How do you run it? How do you get the best grade possible? Okay, you can run your projects on whatever systems you have access to, although you can do all the projects on OSU systems. And some of them you'll have to, like the last one, the MPI. I doubt any of you have your own cluster, although you could, or you could have access to somebody else's. But you can do everything on OSU systems, or if you can make it work on your own, have at it. Timing, yep, there's this percent %LF for long float. That's how we print doubles. How reliable is the timing? Well, it depends on the system you're on. And if you're on Flip, if you're on one of the Linux systems, if you type the word uptime, it'll print out, how long has it been up? Well, it's been up for 96 days. That's not what you care about. What you care about are these load average numbers. Is given the people that are on it right now, this is the load average for the last 1 minute, 5 minutes, or 15 minutes. Those are not bad numbers for Flip, but sometimes Flip gets up into the like 15s. And at that point, you probably shouldn't take your test numbers because there's going to be so much competition for the CPU. You're going to get screwy numbers. Okay, this is something I like to do, and it's in the Project Zero, is basically here is the test, the timing, the pragma, the for loop, the timing is I like to run this some number of times, like maybe 20 times, and get the maximum performance. Okay, get the average too. That's interesting. But get the maximum performance because that's the best. Don't average them. But the reason I average them is if you look at the peak performance and you look at the average, those are pretty close. And so I would trust that. But if you get a peak performance, but the average is like half to a third of that, okay, there's a lot of contention going on the system, and I wouldn't trust that. So that's why in Project Zero, it's doing this number of tries. Yep, here we go, using G++. If you want to play around with it, if you have access to the Intel C++ compiler, you're free to use it, but don't take your final numbers there. And the reason is ICPC is too good. When you do benchmarks, when you do timing tests, it's sort of computing for the sake of computing. Well, I've had cases where ICPC has looked at that and said, well, this code isn't actually doing anything. I'll just delete it. Well, then in that case, your performance gets really, really good because it deleted everything it was doing for the test. So do not use ICPC for your final numbers, but it is interesting to play with it if you've got access to it. Yes, we're going to do graphs and we'll talk about that. So on our graphs though, let's all do up is faster. So don't plot elapsed time because then up would be slower. Plot performance, megamults per second or something like that. Let's make up be faster because that way we can compare graphs and see if we're getting roughly the same results. Graphs, again, the major is called computer science. I expect scientific literacy in your graphs. I expect axes with numbers and labels on them. Okay. I expect to be able to easily tell which colored curve goes with which quantity. And again, we'll talk about this. You'll see examples. Okay. Common Linux commands. Yeah, if you're new to Linux, these are things you'll know. This is kind of your lifeboat of Linux commands. Diverting to a file. This will be important for the graphing because if you're printing the numbers, if you divert them greater than, or better yet, greater than ampersand to a file, well, that file can then be used as a direct input to Excel. Like, wow, okay, that's pretty cool because then you don't have to copy and paste your numbers to Excel. CSV is an Excel recognized file type. So if you print your numbers out to a CSV file, you can just read those right into Excel. So I really recommend it. Standard error and standard output, they both print to the same place. Standard output, printf, is buffered, which is smart. It's more efficient. It's writing characters into an internal buffer, and then only when the buffer fills up is it interrupting the system to flush it all out to the console. Standard error, on the other hand, prints every character out to the console. For every character, it interrupts the CPU to send that character out. Tremendously inefficient, but if your program crashes, all your standard error printout is now visible, and hopefully that helps you debug the problem. Whereas your printf stuff is not, or maybe not visible. Okay, so I just got in this habit years ago of always outputting to standard error. You can change it to printf if you want standard out, but that's why it's done that way in the sample code. Well, I know you. If I say do 10,000 of something, you're going to try 100,000 just for fun. I want to point out that if you have, say, 2 dimensions, so you're doing 100,000 points this way and 100,000 points that way, when you multiply 100,000 or 100,000 numbers together, you're going to overflow an integer. And that's going to give you really weird results. So typically, if you're using big numbers and maybe you're multiplying by each other, float them first so that you don't overflow your ints. Turn in, we've already talked about. Bonus days, yep, we've already talked about. And everybody always asks, can we sell our bonus days to other people? No, because if we could, then I would be the broker and I'd be taking a cut, and I'm not. Can you turn them back in for extra credit points? No. No, they're there to use. They're there to make your life run easier. But be real strategic about using them early versus using them late. These are silly ways to learn to lose points on your projects. Okay. These are -5 point things that nobody should be doing. Virtual machines. For some reason, virtual machines have always had this problem with doing multi-threading. So if you're running a virtual machine, that's probably not a place to be using OpenMP. It makes no sense to me why this would be the case. It just seems to happen. So I'm warning you now, if you're running a virtual machine, that's probably not a place to do OpenMP. And Windows, if you use a Windows editor to edit a file and then you use that file on Linux, it may fail because Windows likes to add 2 characters at the end of each line, and Linux expects 1. So there is a nice program called DOS2 Linux where you take in one file, the one generated on Windows, and it extracts one of those characters at the end of the line and puts it out to this one. Okay, if you get some messages that make absolutely no sense, this might be the culprit. Oh, and I threw this in just for fun. We all use the phrase computer bug, but it really originated as an actual bug. Is Grace Hopper found this. This was back when computers had relay switches. So a little bug, a real animal, had gotten into one of the relay switches. So she pulled it out and she taped it into her lab notebook to point out what was wrong. And so the phrase computer programming bug stuck. And this is in the Smithsonian Institution collection, which is just cool. Okay, back to the chat. What about a Docker container? That's a great question, and I don't know. I can't think of a reason to want to need a Docker container. I can think of the fun of experimenting with one. So maybe try it without, and then try it with, and then tell me, and then we'll both know. But I can't think of a reason that it would be absolutely necessary other than, well, now that you mention it, I'd like to know too. Yeah, the Rabbit server is rabbit.engr.oregonstate.edu. But as was reported to me a couple hours ago in the on-campus class, none of you seem to be able to SSH into it. So when we're done here, I'm going to walk down the hall and ask the IT people about it, which is weird because I can get there. I can SSH into Rabbit. So I think they reset something during the spring break and reset the wrong thing. We'll get it fixed. This is not a complicated issue. I think once it gets reported, they're going to look at it and go, oh, there it is. Oh, stay tuned. But Rabbit is essentially the same OS as Flip, so you can use Flip and get all the same uses out of it. What's the difference between a thread and a process? A process can be other things. A thread is an independent path through your program. So if, say, you've got 2 threads, each of them has their own registers, their own stack pointer, and their own program counter. And since they have their own program counter, they can be traipsing through your executable in different places. A thread is a process, but a process is not necessarily a thread. A process is, I would think of a process as a superset of a thread. So a thread is like a processes that work within a single executable. Whereas processes, I can type something on the command line and say ampersand, and that goes off in the background, and it's its own program. We'll get into threads and what it seriously means next week. But for now, just think of it as an independent path through your program. All threads share the same executable. Other questions? In the chat, or you can unmute.
So this might be getting just a little bit ahead, but I watched one of the lectures about not just running a for loop a bunch of times when you want to run it multiple times, because it gives inconsistent results. I was wondering if the same problem would happen. So if you functioned out the application and, like, say I call it with run it on one thread, run it on 4 threads, run it on 8 threads in main. So main just runs the function 3 different times. Does that have the same problem as doing a for loop to run it multiple times?
Well, if you do one thread, then there's no problem at all because there's no contention. Where that comes up and where that note set showed it coming up is if you're doing what's called a reduction. You're adding into a variable. So let's say in the for loop, it was summing a bunch of things. So the first part of the for loop was computing something, and then the last thing in the for loop was sum equals sum plus the partial sum. That's where you get into the problem, because you have multiple threads and they're all adding into the same sum, the same variable called sum, but it's quite possible that the addition into sum starts and then gets interrupted by the scheduler. And so by the time that thread gets back to being executed, sum is not what it was a moment ago. And so it's the trapezoid notes, because it's doing a trapezoid integration. The trapezoid notes show I was doing a trapezoid integration where the answer was exactly 2.0. You can do the calculus and integrate under the curve, but I was getting numbers like 0.3, 0.4, 0.5, 0.25. The sums weren't even close. And that's because they're all adding into the same variable, and it's just not working. Each thread needs to be able to add into the variable without any other threads interfering with that. Okay, so does that make sense?
Yeah, I don't think it was race conditions. I think it was one of the reasons for scripting.
It probably could be described as a race condition, but it's really because of the reduction. When you're trying to do arithmetic, multi-threads arithmetic, but doing it into a common variable, that's where this shows up, is they interfere with each other trying to do work into the common variable.
It was the talking about putting the loops for your script to run it multiple times, because the first time OpenMP runs, it does one-time setup and messes up the timings.
Oh, the num times is there so that if you're on a system like Flip with other people, this will give you the best performance that you've gotten. Like, hopefully, if a whole bunch of people are on right now, maybe a second from now, they won't be. And so when your code runs another time, it's going to get better performance. That's what the num times is all about, is the num times is really trying to take out all the other people you're contending against. It's trying to give you more confidence in the performance number that you get. Yeah, okay. Yes, there are red stop signs at the bottom right corner. Two stop signs means that's the last page in the note set. Some of them have single stop signs. And for some of the longer things, I break up the videos, the recorded videos, into multiple pieces because to do it all in one would be too long. So a single stop sign is a flag for me to end that video there. And then the double stop signs are, this is the last page in the notes. For source files, no, you do not need to include your bash scripts, just your CPP. I'm assuming your script files are fine. I'm assuming if there's an error in your code, if something's going weird, it's going to be in your CPP code, not your bash code. Oh. Yeah, that's the last question in the chat. Yes, if you want to submit multiple results, have at it. I find that really interesting. And that's why in the submission, it always says, tell us what you ran this on. Now, if it's on Flip, you can just say Flip server, and we know what that means. But if it's your machine, tell us what that is. I find it really interesting to do that kind of comparison. It's really interesting when we get to the GPU. You know, because some of you who went out and bought big bad gaming GPUs, your numbers are going to be great. Better than we get on the OSU machines. Wow, good questions. All right, any other questions? With that in mind, I'm going to stop recording.